Hey everybody, and welcome to the next chapter, Setting a Meaningful Index. We have a couple of objectives here. We're going to extract the components of a data frame, and then we're going to understand what makes a meaningful index. So let's get started with extracting the components of a data frame. We'll just import pandas at first. And then we're going to read in a simple CSV. It's just called sample CSV. And I'm going to do something that I'll explain in just a little bit. I'm going to set the index column equal to 0. So here we have a very simple data frame. These are all the rows that are shown here. So we have, first we need to remember what the components are. So, and that's what we just previously learned. So again, the components are the index, which is always in bold on the left-hand side. And then we have the columns, which are also always in bold, and these go on top. Then we have the data, also known as the values, which is everything else over here. So again, the index and the columns are simply labels for either the row or the column. Okay, so in this step, one thing I want to describe is this parameter right here, index underscore call. So this just forces the very first column in the CSV in that raw text file to be the index. So pandas is just placing this column into the index, and I wanted to do that just to show you a data frame that did not have the default index, which we will talk about later, which is just numbers. So we have strings here in the index. Let's go ahead and extract every component. So we have the index, the columns, and the values. So just to show you that these are indeed their own objects, we can do this. So we can extract them, and these are not methods, these are attributes. So we're just going to get the index, so you just do data frame dot index, and that returns the index over here. And then we can get the columns in a very similar way, if I spell it right. You'll notice that they both say the word index out in front. I'll talk about that later. So why are the columns have the word index there? And then to get the actual data, we're going to use the values attribute, not a data attribute. So it's the values attribute. So it returns, actually this is a NumPy array, which we'll find out just now. So let's go ahead and make an assignment statement here. We'll just assign each one of these to their own variable. We'll just call this calls, and I'll output it again. I'll call this vals, and I'll put it here. Okay, so just to verify exactly what we have here, you need to know exactly what the types of these things are. So these are the three components, the index, the columns, and the values, but it helps to really understand exactly what these things are. So this is the type always comes at the very end. So this is the index type, capital I index type, and the columns have that exact same type. So pandas uses the same underlying object for both the index and the columns. So again, the index is simply a label for either the row or in the case of the columns, for each column. And then we have, for the values, we have a NumPy array. Now, we don't deal with the index. We're not going to deal with the index a whole lot, so it is not the most important, object to know. This index object itself. So it's just good to be aware of it, that it is in fact a separate object. You can extract it out, and we'll do just a few operations on it, but just a very few, as it's not something you commonly use. So it's more you use it within the data frame itself, and not necessarily extract it as a separate object. But anyway, so we've verified what the types are. So this is a NumPy array. We're back in NumPy land. We've stripped off the pandas index and the columns. So you can think of a NumPy array and a pandas data frame is very similar, except the NumPy array has no index and has no columns. So you just use integers to access or as labels for both the rows and the columns. All right, so that takes care of the components of a data frame. Let's also extract the components of a series. So before we can extract the components of a series, we need to actually create a series. Let's go ahead and select a single column of data here. So we'll just select the color column. And you can see that, okay, so this is the result. This is a series. And the series has just an index and the data. It has two components. All right. So notice that whenever we selected this column, the index came along with it. So those labels came along with it. It was not discarded. Right. So if we go ahead and put the data back up there, you can see that when we selected a single column of data, the index comes along with it. So this is like, you can think of metadata. It is not actually part of the data itself. So the index will come right along with the values of the column when you select a single column. All right, so let's go ahead and look at these components. So we have color.index. We'll do this again. And then we have color.values to get the underlying NumPy array. Now notice that there are no columns here. So there's no color.columns attribute. But they have the same names for the index and the values. And this NumPy array is simply a one-dimensional NumPy array, as opposed to a data frame which has a which returns a two-dimensional NumPy array. So, but other than that, the index and the values attributes are the same, and that's how you extract them from a series. All right, so above, I set an index directly when I was reading in data. Now, that's not necessarily a common thing to do. So let's read in a different data set. So there's a movie data set, contains some information on many movies. So I'm going to read this in, and I'm not going to do any sort of index setting at all. And let's just print out the first few rows here. Okay, so this data frame still has an index, it has columns, and it has values, or it has data. All data frames have those three components. So the default index, so if you do not provide an index on read, what will happen is that Pandas will create an index for you as the numbers, beginning at 0, going to n-1, where n is just the number of rows. All right, so let's go ahead and extract this index, and I won't save it to a variable. But so this is a little bit different object. It's called a range index. So this is not that important. So you don't have to worry very much about this object whatsoever. It is still, considered an index object, but it's just a very particular type of index object. Essentially, what happens here is that to save a little bit of memory, Pandas does not actually put these integers in memory. So it saves, it can save quite a bit of memory if you have a large data frame. So in this sense, it's sort of waiting to be accessed. So Pandas just simply, it's very similar to the range function in regular Python, in that the numbers are not created until they are, needed. So that's all that means by this range index. So the values are, they're still there, but they're not created in memory just yet. So you won't be dealing with a range index very much. So actually I do use it in the next step. So let's go ahead and assign it to a variable. So we do have this range index. So for instance, if I just want to show you a little bit of selection with the range index, just to show that, or just with any index in general. So with any index in general, you can use the brackets to select a member of that index. Okay, so for instance, I can say select the 20th value, which just happens to be the number 20. So it works very similarly as like a list. So I usually recommend, thinking of a range index to be very similar to a list. So you can select a single value like that. You can use slice notation. So say we want to go from 5 to 10. So this is exactly how you could use it for slice notation. But you can also put in an inner list and select, values like this. So we selected the 10th value, the 99th value, and the negative 4th value. So if you pass in a list here, you can select very particular values in that index. This is not very interesting. You can put negative numbers in, so this is the 4th number from the very end. And notice the data type has changed, so it's a it's like a normal index where the data is actually in memory. But again, all these index types, they're not at all necessary to know much about. You're typically dealing with a data frame, so the index is simply a part of the data frame, and the few times you'll use the index is typically to sort of select some piece of data from it, like I did here with these brackets. So that's typically the most that you'll do, but it is its own object and it has its own methods. All right, let's move on. So we talked about we already did set an index on read in the very first example with that index call parameter. So let's go ahead and do this again with the movie data set. So we'll do read CSV, and we'll read in the movie data set. So let me just go ahead and read this in. So you can, right when you read it in, within read CSV, you can use this index call parameter, and you can allow it to be either an integer or a string. So if you allow it to be an integer, then it will just simply use that integer location to select whatever column that is to be the index. If you make it a string, then it'll match the column name with that name and use that as the index. So here I'm going to use the string title, which means that it'll read in the data, it'll find the it'll find the column name with the name of title, and it'll put that in the index. So let's go ahead and read this in, and I'll reassign this to movie, and I'll just get the first let's just say 3 rows here. Okay, so notice that now my index is no longer the default range index, but something quite a bit more interesting. It's the title of the movie. And notice that title is not a column over here. All right, so it is technically not data anymore. It is metadata. It is a label for every row. So Avatar labels this entire row. Pirates of the Caribbean labels this row, and so forth. So now the title serves as labels, not as data. So that's important. So this is how you set an index on read with this index underscore call parameter. All right. So we've already seen this, but I'll just do it again here. So we can go ahead and extract this index and verify that it has a slightly different type. So here's the index. So it's just the names of all the movie. And we're back to a, just a regular Pandas index. Again, it's not necessary to really worry about all these different types. They sort of behave all very similarly. So they're all similar types of objects. But this is just an actual just index object itself. So we already saw how to select values from the range index. It happens the exact same way with this regular old index. So if we want to get, I don't know, the 40th movie or something, if we want to get a range of movies, say from 200 to 205, this will get those. So you should really think about an index. It's somewhat similar to a list, and that might be the easiest way to kind of think about it when you're first learning. So you can select values, you can use a range, or you can actually just pass in, a list of values like 100 and 200. So we'll get those two movies like that. All right, so just a few tips on how to choose an index. So first, number one, you never have to make an index. So you're never forced to use an index. You can stick with the default index and complete your data analysis just fine without it. It does provide some nice functionality. so I do like to teach it, and a lot of people do use the index, so it is good to know about, but it is not a necessary component to sort of to do data analysis with Pandas. Okay, so with that said, the index, should be unique and descriptive. So if we just look at our movie data frame once again, so since it's a label for the row, it'd be a very good idea if you chose an index that is unique, so that you can uniquely identify that row by that value in the index. Now, Pandas does not enforce uniqueness for the index, which sounds a little bizarre, but you can have duplicates in your index. So that's something that's, if you do have duplicates, it will, it'll still work, but typically you're going to want to choose a column in your data frame that has no duplicates. And of course, it should be descriptive. That's also very important. So if you're going to use an index, you want to use it such that it is a good description for that row. So it gives you, a good label. And of course, the title for the movie is going to be a good description here. So it's probably the best. It's definitely the best column in here to use as an index. So it's now there could be movies with the same name, and we could check that a little bit later. But it's going to be mostly unique, and it's definitely going to be descriptive. So this is going to qualify as a good index for us here. All right, now you can you don't have to set the index on read. So let me just show you guys how to do this. So if we read in the movie data frame without setting an index, so we're back here, and there's no index. Title is now a regular column, so its values are not bold. You can set an index with the set index method, and then you just simply pass in the name of the column you would like to use as the index. So in this case, we just say movie dot or set index of the title, and we get back what we got when we read it in with the index call parameter used. Okay, so now one thing about this, very important, and it's very it's confusing for beginners. So you think you've set the index here. Now when you look again at movie, you'll see that there's no index set here. So it looks like this operation didn't work, even though you can see it with your own eyes right here. But when you continue on to using movie again, it no longer has set the index. So what's happened here is that what Pandas does is that it returns a completely new object in memory. So it does not set the index on the original calling object. When I say calling object, it's the object that's making this call to set index. So movie here is the calling object, or you could say the calling data frame. So we say it does not happen in place. So it does not change this underlying object. It returns a completely new object. So what you'll need to do here is that you'll have to assign this, and we just call it like a movie 2 or something. You'll have to assign the result to a variable, and then and only then will you be able to continue on with the index or the title in the index. So again, movie is unchanged here. Okay, so it does not happen in place. Pandas creates a whole new copy in memory. So yes, if I look at movie again here, we should see that there is no index set, but movie 2, I've made an assignment, so it has its index set as title. Okay, so we could have reassigned it to the first one. All right, just a couple other notes on some options that you can use for your data frame, or for while using Pandas. So when we look at this data frame, you'll see, so everything looks okay, but you get over here right to this actor 2 variable or actor 2 column name, and then you see 3 dots. So that means that there's some columns there that are being suppressed by Pandas, and that's because by default Pandas only shows 20 columns. So that's what it's visible to the users. So that's a little disappointing. We can look at the shape here and see that, okay, we have 22 columns. So it looks like there are 2 columns that are covered up over here. And that's pretty annoying to not be able to see all the columns. Of course, there are times when you would you might want to prevent all the columns from being shown, but it is quite annoying not being able to see everything. So what we can do here is we can change the display options, right? So we can change the display options of Pandas. So first thing is to know how to get the display options. So if we do pd.get option, this is a Pandas level function, and we press Shift Tab Tab, you'll see this is where you have to read the documentation. There's no way you're going to remember all this stuff. You can see all the available options here. Okay, so there's quite a few of them. And we want to look at this max columns option. So it's under this display. So it's display.max columns. I'm going to go ahead and do that. Display.max columns. So you put it in as a string. And okay, so it says 20. So we can change this by using the set option function. So, and this will this doesn't permanently change it forever for Pandas, so don't worry. It's just for this session, just for this Jupyter Notebook session that's open. So whenever you start Pandas again, it will be set back to 20. So don't worry about permanently altering your Pandas. So here's set option, and the way set option works is that you're going to take the option you want to change and put it, pass it to this method. And it's kind of bizarre, but the very next parameter is what you want the option to be. So let's just say we want to set it to 40 or something. So it's going to set the display.max columns option to 40. Okay, let's go ahead and run this. So it's been set, and now let me just copy and paste this here, and we can see, we can verify that in fact the new display option is 40. So when I output movie now, you'll see that after actor 2, there's no 3 dots, so we have our 2 new columns over there. So we've correctly enabled more columns in our for our data frame to be displayed. So I'm not going to go through the options. If you just press Shift Tab Tab, you will be able to see them all, and you can go to the Pandas documentation. If you scroll down here, you can actually see a lot more, so it gives you more information about every single option. But to be honest, this is one of the only options I typically change, is this max columns. I almost always change this one because it's very common to deal with data frames that have more than 20 columns by default. So that's a good one. That's a good one to change. All right. So that completes setting a meaningful index. Now, if you want to learn more, I would suggest that you consider buying the book, Master Data Analysis with Python. So this comes with all of the text, 600 pages. There's a lot of exercises, 300 exercises, multiple projects, and everything in there has very detailed solutions, so you can check your work. You'll learn a ton, and I would be very grateful if you consider doing this and supporting me in the channel. All right, so that's it for this one, and we'll move on to the next section.